Hello and welcome to the Math Studio, where we don't have to wear masks because we is just me and there's no one else around. So let's get right to this. We're going to be learning about the dot product in this video. And so let's go right to, maybe we need to make this a little bit bigger. So what we've been doing with vectors so far is we're adding and multiplying a vector by a scalar, but it's going to be important to be able to multiply two vectors together. And there's two ways that we can do this. One way is called the dot product. The definition is here. It's also printed in your book. Probably the easiest way to learn about the dot product is by doing it. The dot product is just what you get when you take two vectors and successively multiply their components together. So let's go ahead and take a look at another version of this. This is for two-dimensional vectors. You can do this with any number of dimensions. So you'll notice that if you have your two vectors here, you're just going to multiply the components together, and then you multiply these components together. And what you get when you multiply two vectors together in this way is you get a scalar, you get a number. So a dot product always ends up being a scalar. And by scalar, we mean a number, not a vector. Okay, so let's take a look at some examples of this. Starting out, we have 4 dotted with 3, -1. So I'll walk through this with you so that you know exactly how to do this. First thing to do is to write this like this, where you have 2 times 3 plus 4 times -1. And then once you have that, you can add that all up and you should get 2. If you need to, use your calculator, but I hope you can do this part in your head. Okay, onward. What about this? -1, 7, and 4 dotted with 6, 2, and -1/2. And when you, first of all, multiply component-wise, you get -1 times 6 plus 7 times 2 plus 4 times -1/2. And then you just add that stuff up. And I got 6. I hope that's what you get as well. Finally, one more example. And I can't stress this enough, that all you're doing is you're taking the components and multiplying them together one pair at a time. So you see how that works. And then you're adding up the results and you get a single number as your result. Okay, so one more example. This is written in standard basis notation. And here, once again, you line things up. Now you'll notice that there isn't an I over here. And so the I component would be 0. Hopefully that isn't going to throw you too much. So you have 1, the 1 over here, times 0. And then the J components, you have 2 times 2. And then the K components, -3 times -1. Another mistake some students make when they're doing dot product is they like to write the J, the I, the J, and the K over here. There's no I, J, or K. No I, J, or K. I know you love those things, but you're not going to use them here. Anyway, my total is 7. You just get a number. This is a number. It's not a vector. Not a vector. So you take two vectors, and the result is a number. We have some properties of the dot product. These are useful at times. So let me just highlight some of them. If you take a vector and do the dot product of the vector with itself, you get the magnitude of that vector squared. It turns out that the dot product is distributive with addition. And so if you're doing the dot product of A with B plus C, it's the same as A dotted with B plus A dotted with C. There is the 0 vector. Dotted with anything is 0. That kind of makes sense. The dot product is commutative, meaning that you can switch the vectors around and you get the same result. And there is this pseudo-associative property here. It's kind of associative and commutative at the same time. That if you have a constant times a vector, dot product with a vector, it's the same as doing the constant times the dot product, or the first vector dotted with the constant times the second one. So those are just some useful things to know about vectors. Probably the most useful thing, though, about dot products of vectors is this next thing, and that is that the dot product is related to the angle between two vectors. Now, in order to see exactly how you get the dot product out of this, what we're going to do is we're going to use the law of cosines. And so the law of cosines says that if you have those magnitudes, then the magnitude of a minus b squared is equal to the magnitude of a squared plus the magnitude of b squared minus 2 times the magnitude of a times the magnitude of b times the cosine of the angle there. Now, it turns out that you have to do quite a bit of algebra to get from this to the next expression, but trust me that you actually can get from here to this. A dotted with b is equal to the magnitude of a times the magnitude of b times the cosine. So if you really want me to, I can do this for you, maybe in class. So lots of algebra goes here. It's not really hard algebra, but there's a bunch of algebra that goes between this line and this line. So anyway, that is the most useful thing about the dot product, the fact that it's related to the angle between the two vectors. So anyway, here it is in all of its glory, although they left off the parentheses. And so we can use this to compute angles. We can use it to find other properties between vectors. I'm going to pause the video here so that we can start a new video, just so that we have a point of reference.